Gotcha.
So the metric system is a nice, neat way to do your calculations and your measurements in a laboratory. And it's really good because it's all based on a unit of 10, right? 10, like 10 cents is 10 pennies. It's kind of easy. Or, $1 is 10 dimes, and it's kind of based on that, the word cent. So there's a lot of prefixes, and I'm going to pretty much give you the prefixes, and you'll go over a worksheet that I'm going to give you, and you'll have this PowerPoint just to help you. So before you do anything, you really should learn the units. I'm very big on units. Like when we measure length, like the way the Kings do it, the way we do it here is we use like inches and feet and yards and miles, but we use meter. So that's the base unit for length is meter. And you really should write it as a lowercase m, right? So that's the base unit. So you're going to see later on when you do an exponent, it's 10 to the 0 meters in this case. That's the way you'd write 1 meter equals 10 to the minus. Well, not to 10 to the minus, I'm sorry, 10 to the 0. Now, volume, what fills a container, whether it's solid or liquid, it's still volume, is in liters. And usually that's like 1 liter. Here's your base unit. So that equals 10 to the 0 liters. Everybody get it? Now, we say mass instead of weight because mass takes gravity out of the equation. So it is weight, but we call it weight on Earth because we have gravity pull. So this is 1 gram, and that's the base unit, G, gram, and that's 10 to the 0 gram. So you have to memorize these. The volume is liter, length is meter, and mass is gram. So again, we use this internationally, which is a big component. And in medicine and laboratory, we use it only. We don't use anything else. I don't even know what a foot is in a laboratory. And there's less to deal with. We don't have to worry about what dozen means. I mean, you have to worry about what a mole means in chemistry, but that's kind of much smaller unit. So you just have to know fewer units. So here's the main base units: length meter, volume liter, and mass gram. And it's easier to convert from different prefixes, from different numbers within the same unit. So we use Celsius. Again, you can figure out how to do Celsius. It'll show you how to do Celsius conversion to Fahrenheit. Like the freezing temperature in Fahrenheit is like 32 degrees Fahrenheit, and water, say, is about 212 degrees Fahrenheit for boiling point. Body temp is in Celsius, I think it's like 37 degrees Celsius. And in Fahrenheit, it's around 98.6. So it's about 36.6 degrees Celsius, I believe, and 98.6 degrees Fahrenheit. So that's an easy conversion, but it's good to know. So here is the base units, right? You start with the base units. And that would be either meter, gram, or liter. And that's 10 to the 0, not negative 0, just 0. And that would be 1 meter, 1 gram, 1 liter. So this is making the unit bigger, going up, like a deca, and I believe that's written DA, is 10 to the plus 1. So that could be decameter, decagram, decaliter. Then if we go up to a larger hundredth, it's hecto. And hecto is just H, lowercase h. And kilo would be 1,000. So that's 10 to the third. Hecto is 10 to the plus second. Kilo is 10 to the plus third. And that's a small k. So whether it's kilometer, kilogram, or kiloliter. Like you might have heard of kilogram as a weight measure or a mass measure. So these are all getting bigger. Now below are getting smaller. Now I'm going to teach you the decimal point. Like a lot of times you just use a calculator, but let's just use a decimal point for this. So where's the decimal point for 1,000 kilometers or kilograms or liters? It's here, right? It's at the back. For hecto, it's here, the decimal point. And for deca, it's here. And for this one, it's here. So these are all positive numbers. They're not fractions, they're decimals. So you know this is 0 going to come after all of these. So the decimal point in those higher numbers is to the right. Now, as we go to lower exponents or lower units, again, you can use them for all the suffixes, meter, gram, or liter. So these are your prefixes that come before. So now we're going the opposite direction. Where we're moving the decimal point, look where we moved the decimal point to go 10 to the minus 1. We moved it 1 to the left. So to convert to a smaller unit, you move the decimal to the right. To go to a larger unit, you move it to the left. So a decimeter, liter, or gram is 0.1. So you moved it to the left to convert it to meter, gram, or liter. Now centi, you have to remember that. I think, and deci is just a D. So you know the difference between deca and deci. Centi is just the C. And that's 10 to the minus 2. So that's the move the decimal point from the base unit. How many times do we move it? 2 times. Because it's 10 to the minus 2. Now milli is 10 to the minus 3. And milli is just an M. And we move the decimal point 3 times to the left. 1, 2, 3 to go from millimeter to meter or millimeter or meter to milliliter. So to convert to the smaller unit, you move the decimal point to the right, right? Because there's more in the smaller units than there is in the bigger units. And then we skip a few, and I'll show you, I'll draw it out for you, like the ones in between, like 10 to the minus 4th, 10 to the minus 5th, 10 to the minus 7th. We won't write those in here because we don't use them too much. Now micro is 10 to the minus 6, but that's written as a little u, not to be confused with milli. You see, micrometer, microgram, which we use a lot, microliter. Okay, so that decimal point was moved from the base unit 1, 2, 3, 4, 5, 6 times. Yes? And that's 10 to the minus 6. 10 to the minus 9, which we use a lot too, is nano. And nano is just the N, 10 to the minus 9th. You can go all the way up to 12. We can go even further, but 10 to the minus 12 would be pico. Let's write that down for you. 10 to the minus 12 is pico. P. So again, you go from the base unit, which is 1, and you count 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's the number, which is 10 to the minus 9. Notice where the decimal points are. And we're going to use decimal points. You don't have to worry about using a calculator ever for this A&P 1 class, okay? Anybody have any questions about that? So again, go through these and you see the conversions, and this will show you how to do it. Again, we might ask you to go from millimeters to meters. So in this case, you're going from the smaller to the larger unit, right? Yeah, smaller to the larger. So you go this way, 2, 3, because a milliliter is 10 to the minus 3 meter. So I'll do some examples for you. I think that's the best way to do it. And this is the way you would do it as far as using a calculator, and you can. Like if I asked you how many millimeters, or how much is 250 millimeters, which remember is 10 to the minus 3 meters to meters, which is again 10 to the 0. So 1 meter equals 1,000 millimeters. And then you cross these out, you do 250 times 1 divided by 1,000, and you get 0.25 meters. That's an easy way to do it with a calculator. But I want to show you a different way and see if that works for us. And this, you can go even further. You can go to micrometers, right, which is U, which is 10 to the minus 9th meters. In this case, just we're talking about meters, but we could be talking about grams or liters. It doesn't matter, right? And we want to convert that to meters, which is 10 to the 0 or 1. So we have to get 1 millimeter equals 10 micrometers times 1 meter equals 10 millimeters. Right, so you have to get rid of these two. And millimeters, remember, is 10 to the minus 3. And then you'll get your answer in meters, 0.25. But I'm going to show you an easier way. And I think it's an easier way anyway. So this is what I do. Any questions so far? Any questions? And I'll write this out for you. And you have it here for your practice, right? You can practice. Somebody have a question? Can you hear me okay? Can you hear me? Yes, speak out. It's not so bad. Okay. So again, let me draw this out and you'll have this. And I'll send you over some practice for later. So what I do is on the top of the page, I'll start with, say, with your base units, right? Why isn't this writing? Like right here, I'll put 10 to the 0. And that's going to be 1, right? It doesn't matter if it's grams, meters, or liters, because that's just the suffix. Then here I'll put deca, which is 10 to the 1, right? So that would be 10. And then over here, I'll put 10 to the 2, and that's 100. And then over here, I'll put 1000, which is 10 to the positive 3, right? So that's kilo. This is hecto, and this is deca, DA. And this one here is your base unit. And that could be grams, liter, or meter. So those are all your positive numbers, right? There, in a kilogram, there's 1,000 grams. In a hectometer, there are 100 meters. Okay, in a decaliter, there's 10, but the base is 1, 10 to the 0. Now going the opposite way, you have, what was the first one? Do you remember? Which was 0.1. Actually 0.1 or 0.1, 0.1, right? 0.1. And that would be 10 to the minus 1. That was deci, right? Deci. Minus 1, 0.1, 10 to the minus 1. The next one would be centi, which is 0.01. And that's 10 to the minus 2. And that would be what, centi, right? And the next, so draw these out because this is really helpful, I think, with it. But it's really about the decimal point, which makes it a little easier. But again, this is AP1, so we don't want to go too deep in using calculators for everything. So this one here, see where the decimal point is 10 to the minus 3.
That's milli.
Milli, right. And then we move on. We're going to skip 10 to the minus 4. And that would look like this, right? 1, 2, 3, 4. And that would be 10 to the minus 4. We don't have a name for that. I'm not going to put a name on it. Right, then we have 10 to the minus 5, which is 4 zeros, right? And a 1. And then we have 10 to the minus 6, which is 5 zeros, decimal point in front, and a 1.
Micro.
Yeah, 6 is micro. Very good. Which is, I'm sorry, it was written like a U. 10 to the minus 6. So that one we'll name, and we'll convert that one. And then we have 10 to the minus 7. Let me get this out of the way. So we're not using 10 to the minus 4 or 10 to the minus 5. So let me put an X there. Just like that. And then we have 10 to the minus 7, which is 6 zeros and a 1. And that's 10 to the minus 7, which we're not going to name, not going to use, but it still counts. You still have to count that because it is a decimal place. And same thing with 10 to the minus 7, or 10 to the minus 8, which is 7 zeros and a 1. That's 10 to the minus 8. X there. X there. And the last one we're going to use more, which is 10 to the minus 9. And that would be 8 zeros. So you don't have to write too many zeros, right? And it's there. And that is what?
Nano.
Nano, correct. So these are all smaller numbers, but have more zeros. Look where the decimal point is. Everybody cool?
Yeah.
Yeah.
I have a question.
Sure. What's up?
Yes, my question is I'm going to start from the base. We have Deca is 10, who is 10, 1.
10 to the positive first, yeah.
Yes, 10 to the positive 1. And now we have a DC. I don't know the number. It's 0.1 or it should be 0.1.
Yeah, it's 0.1. I'm sorry. Yeah, I'm sorry. That's 0.1 right here. Yeah.
And why is 0.1?
0.1 because you move the decimal place one place, 10 to the minus 1. 0.1. Yes. And then you put it, then you move it over twice. So if you did the conversion, it would come out to be 0.1 deciliters, meters, or grams to 1 gram, liter, or meter. So let's do a practice, right?
Okay.
Let's say we have 750 grams, and we want to convert that to kilograms, which is a bigger unit, right? Kilogram is bigger, right? There's 1,000 grams in 1 kilogram. So this number is going to be smaller, right? It's going to have a decimal point in front of it. So where's the decimal point here? It's there, right? For 750 grams. It's here. Right? So now we're going from grams to kilograms this way. So we're going from a smaller unit to a larger, so we move it to the left. So it goes, so how many points are there between grams and kilograms? Let's count. 1, 2, 3. So we move the decimal point 3 places and we get 0.750 kilograms. So those 3 places, right? Here you see 1, 2, 3 between grams and kilograms. And when you're going across, you have to count the base unit too, which I'll show you. So let's do 200 meters, and let's convert that to centimeters. And I'll give you these so you can practice, and at least you'll have the answers right away. And I'll give you the answer key later. So now we're going to meters, which is a base unit, and we're going to centimeters. So how many places is between grams and centigrade? I'm sorry, meters and centimeters. How many places are there? And remember, here's the, well, actually, let's do 2. Let's do 2 meters. It's bigger. 2 meters. So the decimal point is here, right? So how many places from grams to centimeters do we need to go? I mean, meters to centimeters. How many places are there to this? And remember, meter is the base unit.
2, no?
2, right? So we have to go 2 to the right now. So you'll wind up with 200 centimeters. So we move the decimal place from here 2 places. So the decimal place is here. And the answer is 200. Make sense?
Okay. Yes.
So let's do a harder one. And these are the top 3 you'll get. You'll be able to repeat these and go over this. So here is, let's do a number like 5476.3 milligrams And we want to convert that to kilograms. So which is the bigger unit? Kilograms, right? Milligrams is over here.
Mhm.
So how many places do we go to get to kilograms from milligrams? 1,
6.
1, 2, 3, 4. Let me see. 1, 2, 3, 4, 5, 6. Correct. 6 places. So now here's the decimal point, right? So we have to count 1, 2, 3, 4. We have to put a 0 in front of it to get the 5, 6. So it's 0, 0, 5, 4, 7, 6. Makes sense? And 3. There's a 3 there, right? So that's the answer. 0.0054,763. So we move the decimal plate 6 points. That's exactly right. From milli over to kilo. Make sense? So practice those. I'll give you a practice. Like let's do one more. Let's do 6 kiloliters. Let's convert that to milliliters. Now we're going the opposite direction, right? We're going in the decimal point is here, right after the 6. So we're going to a smaller unit, if you will. So this number is going to be much larger. So we're going to move the decimal point from left to right. How many places? Let's count. From kilo, so it's 1, 2, 3, 4, 5, 6 places, correct? 6 places. So this is going to be 6, 1, 2, 3, 4, 5, 6. And here's the decimal place. So you moved it 1, 2, 3, 4, 5, 6 to the right. Got it? So practice those, and you'll do your virtual lab, so you get a lot of different ways to do this. So just keep this in mind for when we do the exam. It's a little helpful, right? Now, scientific notation, right, is kind of shorthand, so you don't have to write all these zeros like we're doing. Now, you'll have a couple of questions on the exam with the zeros, but you want to convert things. Like say there's too many zeros. Let's say you have a number like, and this is one you should get on the practice. You have 1, 2, 3, 4, 5, 4, 5, and 5, 4, or 1. And we want to convert that number to scientific notation, no matter what it's measuring. You don't have to worry about kilograms or anything like that. I'm just doing scientific notation now. This makes things a lot easier. And you might have seen this before. So what you do is, this is a small number, right? This is going to be a minus exponent, correct? Does that make sense? So what you do is you take the first whole number, which is not a 0, which is 5, and put a decimal point, then 4, right? And you can put the 01 if you want, but you really don't have to. You can put 501, 401 times 10. And it's going to be a minus number because it's a negative number. Look where the decimal point is. And how many times did we move that decimal place? 1, 2, 3, 4, 5, 6. So it's going to be 10 to the minus 6. Make sense? Like a simpler one, like 813. The decimal place is here. You want to convert that to scientific notation. You put the decimal place after the first whole number, which is 8 in this case. It's easy. And it's 8.13. Oh, shoot, sorry. 8.13 times 10 now, because this is a couple of decimal places. How many times did we move the decimal place here? 1, 2, right? 1, 2. And it's 10 to the positive 2. Because that's a positive number, right? It's not a decimal. One more we can do. We'll do 7. And we'll write, let's see, 3, 9 zeros. And here's the decimal place. So what you do, you find the first whole number, which is 7 in this case. Right? let's do it. Yeah, this is going to become it's a very large number, right? So it depends where the decimal place is. Decimal place is here. You go backwards. So you go 10 times 9. I'm sorry, 10 to the 9th, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So it'd be 7 times 10 to the 9th. And one more, because this would be negative. If you have your decimal point and 0, 0, 0, 0, 7, 3, right? This one, the first whole number is 7 and 7.3. And how many times you move the decimal point? 1, 2, 3, 4, 5 times 10 to the minus or positive here. It's always minus because the decimal place is here. So it's 10 to the minus what? 1, 2, 3, 4, 5. Okay. So this is recorded and you can go through that. I'll send you some practice and I'll give you the answer key in a couple of weeks. So you can, if you want me to look at it sooner, let me know, send it in and I'll look at it, but practice. And then when you see the answer key, see how you did. And you'll look through the, you'll do the virtual lab on it today. So you'll see how that works.